So today we're going to look at a pretty common task when it comes to biomedical animation, which is creating blood flow animation. So we're going to do something like this. There are different ways of approaching this. The two main ones would be using nParticles, and there are great tutorials out there on how to do that. One in particular by a BMC graduate, Karyn Ho, which I'll link to in the description here. But we could also try to use MASH for achieving this. Now, there are some benefits to using MASH and some weaknesses and some just general Maya weirdness that comes up. But we'll look at all these things together. So in terms of what we're going to do here, we're going to build this up bit by bit. We're not going to model the blood cells, but we're going to talk about how we can use MASH to distribute these items on a curve, how we can bring in more than one item using the ID node. We can randomize their position a little bit. We can even animate their position while they move along the curve using a signal node. But most importantly, we can use MASH dynamics using the rigid body bullet solver to have them interact with each other and their surroundings. So I think this is one of the greatest strengths of using the MASH method, because we can have the actual geometry of these particles or these instances in MASH interact with each other in a very physical way. Whereas if you use nParticles, the particles themselves will collide with each other, but not the geometry which is instanced to them, which is a bit of a weakness of the nParticle system and the instances. So not that this is a perfect system, and you'll see that we have to do a number of workarounds to make it do what we want, and there are some potential crashing problems and just sort of strange behavior that I haven't resolved yet, but this is a starting point. So we'll deal with this one step at a time. And just to be clear, I'm borrowing a lot of the initial setup from a tutorial by Ian Waters, one of the creators of Crash, and I'll link this in the description below as well. But MASH Dynamics number 5 from a few years ago talks about how to animate items along a curve and how to layer dynamics on top of that and some of the pitfalls involved. Okay, so let me just hide this. So we're going to have something like this. If I play the animation, you can see that there are dynamics going on. These things are trying to keep separate from each other. Not always perfectly. There are some problems here, and I could probably set this up a little more carefully to help avoid these things, but there will always be some issues like this, but we'll see as we go along. But the important part here is that we are able to bring in different types of geometry into the same system. So we've got the red blood cell, platelets, and back here leukocytes or white blood cells, and we can to a certain degree control their distribution in the sense of how many, the proportion of red blood cells to platelets to white blood cells. And now it's a little imprecise this way, and I think this is also one of the weaknesses of the MASH method. However, I bet there are people out there who could program this using Python to avoid this problem. So we're not going to model these things, but I modeled these kind of very roughly to their appropriate size. But red blood cells are about 6 to 8 micrometers in diameter. The white blood cells vary depending on what type of white blood cell you're talking about, but let's say 10 to 12 microns in diameter, so they're going to be bigger, and they are here. This one is just behind. And then platelets, the thrombocytes, these little cell fragments, are tiny little things. They kind of look like contact lenses here in mine, but we'll look at how to develop these things. So I think the first thing to do is to just start out by building a rough MASH network and show how we can animate things along a curve. So I'll start a new file and we will begin with that. So here we are in a new file. So I'm just going to create a MASH system. So we'll start with something simple, just a cube, and we will go to MASH, and create a network, and we'll use an instancer network just to keep it lighter, and we'll leave the default linear distribution, and we'll get what we expect here. Now we want to put these on a curve using the curve tool. Let me just move this out of the way. So I'll draw a curve. Now I'm going to draw a curve, an open curve, and show how we can attach things to a curve, but you'll see there's a limitation to this when we want to add dynamics. So ultimately we're not going to use an open curve like this. But to start, we can look at the mesh waiter node and add a curve node. And then in the curve node we can middle mouse drag a curve object in there, and you can see now the mesh has somehow attached itself to the curve. It's not working exactly as we would expect. And to fix that, we have to go back to the distribute node, and the distribution type is linear, and the distance along x is 20. If we just set that down to 0, now we just have the curve controlling the distribution. So if we go back into the curve node, we can change the step amount, and that's how they're distributed along the curve. So if you go to 1, it's going to fill the entire curve. If we can go back to distribute and increase the number of points we have. Animation speed is what you would expect. Oops. I'm just going to add some more frames. So if we play the animation, we can see they're moving along, and we can turn up the animation speed or turn down the animation speed here. And you'll notice that when one of these objects gets to the end, it's recycled and goes back to the beginning. Now this is where the problems emerge for adding dynamics to this, and I'll show you what I mean in a second. So we want to add dynamics so these things could bump into each other. So to see that more clearly, we're going to add a random node, and that just randomizes the position of these mesh objects around the curve. Sometimes these don't show up right away, so the mesh editor should be showing us a random node, but it's not. It is here though. Okay, it's back. Just had to reopen the editor. So the random node we can use to offset the position slightly, and we can randomize the rotation as well. So this is not an animated property. It is, by default, it is just changing their initial position. And we can go back into distribute and add more. So we just have a lot so they could bump into each other. So if we play the animation now. Okay, so now the next thing we're going to do, well, first I'm going to save my scene. We're going to add a dynamics node, and what we'll see right away is that the dynamics just takes over and they fall down to the floor plane that's put in here. So when you make a dynamics node, if you're familiar with MASH, it adds a bullet solver, so it uses the rigid body bullet solver to do its dynamic interactions. So you control the dynamics with the bullet solver, but also in the MASH node we have a MASH dynamics tab, and we're going to do most of our work here. So the important thing to change right away is the MASH bias settings. So position strength will let MASH take over the movement of these things, but still allow them to interact and collide with each other. So now if we play the animation, we can see they're traveling along the curve, bumping into each other, but we see this strange thing happening. So we saw before that by default, with the curve node, when a particle gets to the end, it goes back to the beginning and starts again. When we add the dynamics node, it looks like it's forcing them to physically, well, virtually physically move to the end, and we get them retracing their steps backwards, and we get this weird behavior. So this is a problem, and there are a couple of ways we could try to solve this. So for instance, in the curve node, you can tell it to stop at the end of the curve, but then ultimately what we get is just a bunch of these mesh objects piling up at the end and not having it repopulate as it continues. So I think probably the best solution, and there may be other solutions that I'm not aware of, is to not use an open curve but to use a circle. Now this will maybe limit the way you are able to use this in different types of animation projects, but I'm just offering this as a potential solution. So if we go to create NURBS primitive circle, I'm going to make a big circle, and here is an important point. I scaled this up and I'm going to use it as my path in the curve node in Mesh. I have to make sure I freeze the transformations of this object. So let me undo that. So because I scaled it up, we have scale XYZ 36.7. That will cause problems when you attach the mesh object to this. So just make sure you freeze the transformations of the curve and probably delete its history just to be safe. That initial curve I'm just going to delete and then go back to my mesh curve node and add this new NURB circle as the input curve, and we'll get something like this. So now that it's a continuous curve, we can just have the animation going around and around. I'm going to turn up the animation speed a little bit. So here's another problem that I noticed can happen, is that when you do certain things, like make the animation too fast relative to the size and the strength that the particles are bound to the curve, you can get things happening like this. Okay, it's not happening now, it's because I changed it part way, but if I turn the animation speed all the way up, let's see. So yeah, you can see how it's sort of contracting, pulling in. That seems to happen. It probably works logically based on the settings here. So you just have to be careful with that, maybe not have the animation speed so high. But another thing you can do is go into the Mesh Dynamics node, and the position strength, which is biasing it towards the mesh settings, can go beyond 100, and this is from the Ian Waters video. I learned this. So if we go to something like 500, it can help keep them locked to the curve. Not working here. I noticed that this does seem to, the speed along the curve tends to override that. So the other thing to do is to reduce the speed. So that's one of the limitations, and there may be a solution, but I haven't found it yet. So in our Mesh Distribute node, I'm just going to add more points. So this is one of the real benefits of Mesh, is that it's so flexible to experiment with different numbers. So right now I've got 62 points, but if I wanted to change it to 200, let's say, it's not hard to make these changes. And we get instant feedback. And I could decide that I want to increase my random position, so they're spread out a little bit more. And again, we can see that immediately. So I'm going to reduce this to 1.5 in X, Y, and Z in the random node, to have something like this. And you can see they're bumping into each other and rotating. And if we go back into our my dynamics node, I know I'm jumping all over the place here, but the main places I'll be working are the dynamics node and the curve node. The position strength under Mesh bias is set to 500, but there's also rotational strength. So whether we want Mesh or the dynamics to control the rotation, we can control that here. So maybe we want it to be sort of 50-50. So there's nothing really acting on the rotation initially, so it's just going to be the dynamics here, but it's damped down to a certain degree because of the bias towards Mesh. Okay, so now we've got our particles flowing along a curve. The next thing is to add our instance geometry rather than just this cube. So I'm going to import some already prepared files. Or models, I should say. So we have a little platelet here, red blood cell, and a white blood cell. Now I think the white blood cell is actually too big, but it is a good time to note that when you make a change to any of the models you're going to instance to MASH, you have to make sure that they're at the middle of the world and that their transforms are frozen. So for example, here's my white blood cell. I'm going to scale it down to be just a little bigger than the red blood cell. But now you can see its scale is all off. We want the scale to be at 1. So to fix that, we can go to Modify Freeze Transformations, and we go back to this native state. And just to note, we have everything at the center of the world here. Okay, so to add this geometry into this existing MASH network, we can go to the instancer node. So the MASH instancer node shows the objects that are instanced into the MASH network, and we want to add these 3 new pieces of geometry. So normally you could middle mouse drag geometry into here, but it doesn't work that way with this node for some reason. So we have to copy the instancer tab. So this allows us to have it open even though the instancer isn't selected, and we can select these 3 pieces of geometry here, red blood cell, white blood cell, and platelet, and we can add these selections. So just to note that the instancer node works based on an index. So there's an index of objects 0, 1, 2, and 3. So there are 4 objects in the index, and by default it will only select the first object in the index. So if we delete this polycube, so remove this item from the instance, then you can see the red blood cell becomes the first item in the index, number 0, and it is the one represented. Now, the next step is to make sure the white blood cell and platelets are also represented. And to do that, we have to add another MASH node. It's going to save my scene. And that MASH node is the ID node. So if I click on this, and now before I do this, I'm going to say that every time I've done this before, it's crashed. So let's just see if it crashed. So I just saved add ID node, and it crashed. Okay, so luckily I saved my file just before I tried to put the ID node on, and I don't know why it always crashes. It might be that it does this because there's already a dynamic node on here, and there's intersections between the geometry, and by adding the ID node, it's going to try and swap in new geometry. It didn't do that when we swapped out the polycube for the red blood cells, but it seems pretty crashy. So you could just add these 3 pieces of geometry at the very beginning before the dynamics node is created. I was doing the cube just for demonstration purposes, so but just be aware that it could crash. Anyway, back to the MASH network, and we're going to add an ID node. Didn't crash this time. And when you add the ID node, if you have a number of objects in the instancer index, it will set the ID node to match that number. So the ID count is set to 3. Now, if we add more objects later on, we have to update this number ourselves. Set this to random, and now we can play the animation. And you can see that these things are interacting based on their new shapes. If we go into the bullet solver, if we go into the MASH dynamics node, we can see that the collision shape is set to automatic, and this is usually pretty good. We could also set it to mesh, which will try and match the shape of the mesh exactly. Both seem to act pretty similar. There are simplified shapes that make the interactions quicker and more reliable. So if you actually had models that were box shaped, it might be easier to use this, or if they're all roughly spherical, you could use the sphere shape and it would just be quicker to evaluate the collisions. But since we have such differently shaped objects, let me just hide this, we have to use automatic or mesh. So one of the interesting things about this process is that we can add collision objects here. So if I just create a sphere and move it in the way of these cells, to make this a collision object, we have to go to the bullet solver, and we can see there's a field for collider objects, and we can just middle mouse drag the polysphere into there. And you can see they're mostly interacting. I can see that the platelets, those tiny little pieces of geometry, are sometimes passing through. Now, just a note on improving the collision accuracy here. There are a couple ways to do this, but they're both problematic. Well, at least one is problematic. Normally, if I had collision problems with the bullet solver, the first thing I would do is turn up the internal frame rate here at the bullet solver node. This is really the number of times that Maya checks per frame, checks for collisions, so to avoid interpenetration. However, what I've seen with this and this setup that I have here is that it starts to break away from the curve when we do this. So let's just see if we turn it up to something like 240 frames per second. First of all, it's slower, but we'll also start to see, you can kind of see it here, yeah, that everything is moving away from the curve again, being drawn in towards the center. So again, I don't know how to solve this, but just to bring it up as a potential issue. So it's 60 frames per second or 60 megahertz. It's doing a pretty good job, probably good enough for what we're trying to do here. But just be aware that that's a problem. I'm just going to get rid of this sphere. So let me just save as. So because this is a mesh network, I can still go in my distribute node, turn up the number of points if I want to, and hopefully it doesn't crash. So that's 400, and if we play, now you'll notice at the beginning of the animation, they're intersecting, and when we start to play, they'll push each other apart. So if you're rendering this out, you probably don't want to render at the first few frames at least. There's always going to be some problems with the interpenetration of objects, but that's when it's at its worst. Now, you can, in the dynamics node, set an initial state. So we could have them push each other apart and then set an initial state. But what I've found is that it breaks down the curve animation then. So it's best just to play for a few frames before rendering. So the last thing really that we want to solve is the distribution of the different cell types. So in this case, they're probably evenly distributed, but it looks like they're more white blood cells because they're bigger. In reality, there are far more red blood cells than anything. So we have to find a way to have a majority of red blood cells and then platelets and then just a few white blood cells. And so there are a few ways that we could do this. Now, I suppose we could have different MASH networks for each one, having them all assigned to the same curve and just changing their numbers that way. And I think they could still dynamically interact with each other if they are all part of the same bullet solver. Haven't tried that. I'd like to find a solution where we just need one MASH. So there are two ways I think we can approach this. So the first way is to go into the ID node of the MASH network. Excuse me. And under here, the strength node, or the strength menu, we can change the random strength, if we just pull it in a little bit, we'll start to see fewer of the final index object, which in this case is platelets. So we can just see one platelet here. There's another one here. There's another one down here. So that's one way. It's a very rough way to do this. It's just an approximation. And in fact, it's not the platelets we want to control so much as the white blood cells. So what we have to do then is go into the instancer node and make the white blood cells the last one in the list. So we can say move down here. And then it always does this weird selection thing. So now we've got far fewer white blood cells. And we can go into the ID node again and just tweak this amount. So as it goes down, so now we just got a couple white blood cells, which is probably more accurate. We may want to have a few more, but okay, so that's working. Another way we could approach this problem is actually to add more red blood cells into the mix here. So rather than just adding one red blood cell, one white blood cell, and one platelet, we could actually make duplicates of this original red blood cell and add these to my instancer list. So if I open up my MASH instancer again, copy the tab, and grab those 3 new red blood cells, and add selection. Now it's not going to change anything right away because our ID node doesn't recognize these 3 new things yet. So I'm just going to try and first put these above the white blood cell and the platelet, so it changes the order of the index. Now you can see all we see are red blood cells. And that's because our ID node is set to only recognize an ID count of 3, but we've actually got 6. So we change this number, and now we've got lots of red blood cells, very few white blood cells, and fewer platelets than red blood cells. Again, we can go in and tweak the randomized strength value to get a few more white blood cells in here. So that's still probably too many, but that's okay. It's not meant to be a perfect simulation or anything, obviously. So you can see they're not really moving around very much. If we want to add some initial movement to these cells, we can still go back into our MASH network and add more items. So now this doesn't always work the way we want, but we can try to make some initial animation by adding a signal node. So a signal node is like a random node, but it's animated. So I'm going to change the order of these a little bit. So the signal node I'm going to bring before the dynamics node. And I think I'll bring the ID node before the curve node, or just after. It doesn't really matter. Let's make sure this all still works. Save my scene. So you can see they're moving now because of the signal node that I added in there. And so because we have a MASH bias on the position, the signal node is allowed to influence the movement of the MASH objects, but they're still bumping into each other because of the dynamics. And you can go in and change the signal node to whatever settings you want. So 4D noise, I can change this to local, I think. You can also have it influence the rotation of these objects. Now we don't want to add too much here. I don't really see much happening with the rotation, actually. I'm trying to follow 1 or 2 to see if I can see the change. But you can play around with these different settings. There are different types of noise to use. Change it to curl noise and see what this is like. So it kind of depends on how much motion you want here, but you can see this is adding some initial movement, but still allowing the dynamics to work. Okay, and then finally, the last thing that we can do here is add a vessel for these to move through. And there are different ways of doing this, but I'll just use the method that Ian Waters used in his tutorial. So it was kind of handy, so save my scene. Make sure I increment, oh I don't, okay, save scene. Turned on, so just make a cylinder. Change its height, subdivisions around the height, something like this, and then its radius, make it bigger, and we're just going to delete these end faces, select a vertex, control click to faces, delete those faces, vertex, control right click to faces, delete those. So this is one of those things that I've just learned recently, but I had should have known a long time ago. But I can take this cylinder, I'm just going to delete its history and freeze its transformations, shift select their curve, and go to deform, curve warp, and it will warp that cylinder around the curve, which is great. And we just want to turn off keep length, so we'll wrap it all the way around. And if we leave this turned on, then we still have our max scaling if we want to increase or decrease its size. So it's pretty handy actually. And then we can use this too as a collision object. Now you might want to set this up as your actual vessel that these blood cells are traveling through. But I would recommend probably using this as sort of a dummy object, so a non-renderable object, and then duplicate it and make your renderable shape render where you might want to cut out some faces. So if we go into our bullet solver again, and I add this cylinder as a collider shape, and then we should see, oops, don't play backwards, that these particles will now collide with this shape. So if we just want to, I could hide this. I think if I hide it, it will still act as a collider. And they can bounce off the surface and interact with it in that way. So a bit of a long tutorial with lots of steps, but MASH can be used to simulate blood flow with certain workarounds to make it work in the way that we want. If you have to do more elaborate recreation of blood flow, then you can turn to the nParticple method, which also has its limitations. But I hope you find this helpful. Try it out, and if you find better solutions, let me know.